Hello, AP Statistics. So you've got a numerical graph. Maybe it is a stem plot, maybe it's a dot plot, maybe it's a histogram. Okay, some sort of numerical graph, and now you've got to talk about it. So in class, what we did as an activity was we had everybody look at the following 6 graphs and try to pick out the main features. And anytime you go to look at a graph and you want to talk about it, you want to say what you see, you need to be thinking about what story is this graph telling me, or what do I see? So I'm going to look at this first picture right here. It says, presented below the dot plots of hypothetical exam scores for 12 different classes. What strikes you as the most distinctive difference between the exam scores of class A, B, and C? So I'm looking over here at this number 1. All right, so I'm looking at this, and like maybe I'll zoom in here a little bit so we can move this over. So I'm looking at, I zoomed in too much. Now we go back. All right, so I'm looking at class A, B, and C. And so we talk about, what do you see? What is the main difference here? And if you notice, they're all kind of a similar shape. They kind of look like they're sort of like a little bell curve, maybe, you know, mounded up in the middle, kind of slanting off to the sides. They all have about the same left to right spacing. We're all about 40 to 80. That's about 40 units, 50 to 90, 60 to 100. It's all about 40. But if you look at these, the story that this graph is telling is that class A, on average, did better than class B did, which did better than class C did. So not every single student did better. Okay? There are definitely students in class A who did worse than students in class B and C, but on average, they did better. And so that number, that on average, we're usually looking at sort of like the mean or the median, looking for kind of like, where is that graph centered? Okay, so the main difference here, the thing that really tells the story is, what is that average value? What is the central value of that graph? Okay, what is the central value? That's the thing that I'm interested in. If we go a little farther down here, I've got 2 more classes. Now, these all have, you know, pretty similar centers. They're all centered at around 70. And that's not the story that is being told, though. So when I look at this this graph, what I see as the difference is that the first one just seems so much more spread out than the middle one is, and even more so at the bottom. The ones at the bottom, class D, are more alike to each other than F is. F has a lot of variety in the answers. There's a lot of different values here. One thing also, all the way from 40 up to 100, it's much more, like I said, spread out. So sometimes we would call this the spread. Oop, except for I can't spell spread. Let me try that again. All right, so spread. So the spread of the graph, specifically in this case, if we're going to talk about the range, maybe, the first F here has a range of about 60 units, whereas the last one has a range only about 20 units. Another word that we typically use for this kind of value is variability. The first graph, F, has very high visibility, whereas the third distribution there, D, has low variability. There's not a lot of varied values in there. They're much more alike. Down here on G, H, and I, you know, if you look at the ranges, we're looking at a range of about 60 on each of these. They're about the same width. And when you go to look at average, honestly, they all look like they average somewhere between 40 and 50, so that's pretty similar. But what's massively different about this last one is the shape of the graph. The shape is very different. If you take a look at class I, most of the values are kind of here between 40 and 70, and then it sort of like trickles off to the left side. And then over here we have a ton of values right here between maybe 30 and 60, and then this one kind of trickles off to the right side. So those two are almost opposites of each other. They're almost mirror images. Down here at the bottom, though, class G, you have a lot of values in the center, and it seems to be sort of trickling off on both sides there. So the shape of the graph is different. The way the points are shaped, are molded around this graph, that we see this varied shape here. Now, we'll talk about the words for that here in a second. Okay, now I'm going to go back up here to the top. So class J, like what do you see as the most distinctive feature? If you were going to look at this graph, what do you notice? And what a lot of students said they noticed today was that it looks like the average is about 70, but yet there's only one value at 70. So even though the average is 70, that's not a really good summary of what happened here. What really the story this is telling is a story of two groups. You have a high group and you have a low group. So the high group has an average somewhere in the 80s and the low group has an average somewhere in the 60s. That's why we're kind of seeing that overall of 70. But really, this is a story of two groups of data. Okay, going back here to class K, what do you notice about class K? And a lot of people notice right away there's like a big clump, here in the middle. It looks a lot like class D over here. But there are these two little values hanging out down here on the left and the right that seem really low. This seems really low compared to this middle part, and the other one seems really high. And sometimes we might say that could be an outlier or an unusual value. I'm gonna put a little question mark here. Maybe an outlier. Now, we do have a definition for outlier. It has to be 1.5 interquartile ranges above Q3 or below Q1. We haven't talked about that yet. That's going to happen in a future chapter. So for right now, what we're just trying to inspect for are values that seem not just high, but like unusually high and don't seem to fit the trend of the rest of the data, or low, but like unusually low. So not just the lowest number or the highest number, but something that makes you stop and go, oh, wow. Okay, like something what happened there? Okay. Now the other class here, class L, okay, what you ought to notice in here is that this is perfectly symmetrical, 70 in the middle, and then the bars are down the height. They are all perfect symmetry. This is something that we would want to note. Okay, it's raised in the center, and we have a perfect symmetry as we go down. And this graph over here, graph G, okay, if I was looking at graph G, it also, I might call that symmetrical as well. Okay, but not perfectly symmetrical. This graph over here is more approximately or roughly symmetrical. It definitely is not perfect. But if you did fold it in half, the high values kind of match up together, and then it trickles off on both sides, and those values would match up. Class I is definitely not symmetrical. If you fold class I in half, you're going to have the larger bars matching up with the lower bars. That definitely doesn't work. So it's okay for us to say it's approximately, it's pretty close, it's roughly, that's okay in our class. Okay. All right. So to formalize this a little bit, when we write about numerical data, okay, a lot of people want some sort of guideline so that they write about this. They know what to say. In order to get all those AP points, and we want to make sure we get all those little check marks, there are a couple things that you can look for. The one thing to remember, though, is every time you write, you need to stop and ask yourself, what story is this graph telling me? What is the point of what I'm looking at? So even if you find certain elements and you write about them, always in the back of your mind say, and I think this is saying what to me? So I want to remind you that when you write, one thing you always want to include is context. And in statistics, context usually means that you want to mention the variable or the unit. Okay, so if you're talking about length in meters, then you want to make sure in your writing you reference that you're referring to length, and you refer to those units. And so it's not just a 5, it's a 5 meters every time you do that. The other thing that you want to do for context is you usually want to defend your answers or your thoughts by using actual numbers, okay, whenever possible. So it's much more powerful to say that the mean is 37 meters than it is to say that it has a high mean. Okay, if we can actually find that value and incorporate that, that'll give us a stronger answer. So the acronym I like to teach students in order to make sure you get all these things when you write is SOCS. Okay, I like to put on my socks and talk about numerical data. All right, so the first thing that we are going to do with SOCS The first S stands for shape. Now, I always want to start with the shape of the graph if possible, because in future chapters, we'll have a choice between referring to the mean or the median, and you make that decision based on what the shape of the graph is. So if you've already identified the shape, it helps you proceed forward in the right direction. So I want to look for shape first. Now, there are a couple words that we can use to describe shape, and it's also okay to describe shape in plain old ordinary English too. But one of those words that we use is one that we used on the previous couple of examples, and that is symmetry or symmetrical. So in general, if something is symmetrical, it feels like that you should be able to draw a line right down the middle of it, and it should fold in half and for the most part lay on top of itself. It should mirror itself. Sometimes, however, we don't have perfect symmetry. Sometimes we would only say that something is approximately symmetric. So be careful and use those weasel words. If something isn't perfectly symmetrical, make sure that you throw that word approximately in front of it or roughly. For example, this histogram over here on the right is not perfectly symmetrical. The bars don't match up exactly, but for the most part, it seems to be a mirror of itself. Also, if I look at the stem plot, and again, I kind of want to tilt my head to the side, and I want to look at it like a number line, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so I think, well, here's the peak of the graph. Okay, that's the highest point. And if I look on the left, I've got like 1, 2, 3, 4, 5. There's like 5 bars on the left side, and then 1, 2, 3, 4 bars on the right side of data. Now, obviously that's not perfect, but they do seem to sort of trickle off in the same, and it's fairly close. So we're usually pretty safe to say that something like this is approximately symmetric. I would feel much more comfortable saying approximately symmetric here than I would saying like skewed to the left. Now, if one of them dropped down and looked like a real tail, then I might go ahead and say that, skewed to the left instead. Speaking of that, which we haven't talked about, is this skewed right and skewed to the left. So the skewed to the right, what you're looking for is a graph that has a peak, and then it tends to have this tail on the right side of the graph. So it seems like stretched out. It seems like it's got this drifting off set of values over on the right side. Okay, so it comes to a peak and then it trickles off to the right. It's got this tail on the right side. We can see that shape here. Here's the peak. If we kind of look at the side, okay, there's 2 bars over here on the left of the peak, and there are 7 bars over here on the right of the peak. So we're getting this sort of, if we were to imagine this vertical, we're getting this tail shape over on the right side. That's skewed to the right. You can also think of it as positively skewed. And I like to think of it as the tail is running away towards positive infinity on a number line. On the other side of that, you could have negatively skewed. Negatively skewed or skewed left means that tail is on the left side. So it rises to a peak and then it drifts off. Okay, so you can see that here with the histogram as well. Rises over, sort of drifts off over here on that side. And then same thing, here's my peak on my stem plot. Looks like there's like 2 bars over here on the right side, and we've got those 7 bars that are sort of drifting off on that left side. Again, you got to turn your head, okay, and look at it, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, and this is kind of dumb, but I heard this at an APSI, and it has made a difference for some students. So, when in doubt, there's a left skew in your left shoe, and there's a right skew in your right shoe. So if you think about your foot, for like most people, so inside my shoe, most people, their big toe is the biggest toe. Okay, and then they've got all their little toes drifting over to the right. Or if you've got your other foot here, your big toe, and then it kind of trickles off, and maybe, hopefully your toes don't look as bad as the ones I'm drawing here, right? But you got a left skew in your left shoe, and you've got a right skew in your right shoe. So worst case scenario, if you're looking at a graph and you can't remember the skew, think about your foot. Does it look more like my left foot or my right foot? If you wear flip-flops to a test, it's almost like cheating. Okay, now another word that we sometimes use to describe shape is the word unimodal. Modal comes from the word mode, like mean, median, and mode, so the most frequent value. Okay, so what we're looking for here is a graph that kind of looks like a mountain for the most part. It's a graph that rises to a single peak. Okay, so we're looking for a graph that has one peak. Okay, a lot of these graphs have one peak. So these left skewed and right skewed graphs that we had up here, also those were unimodal graphs. This symmetric graph here, the very first one, this is a unimodal graph. Okay, now that unimodal mentions the peak. So if you're talking about something being unimodal, don't forget to also mention whether that what happens on the other sides of that peak. Is it unimodal and symmetric approximately? Is it unimodal skewed left, unimodal skewed right? I would rather you mention the symmetry or the skew if it has that over the modality. Another idea is bimodal. So bimodal means that you've got two peaks. But another way to think about bimodal is usually oh wow, that is terrible handwriting. Usually a bimodal graph has two groups. Okay, so you're looking for something that appears to have two groups. Okay, so this graph right here, I've got two peaks, but ultimately what I have is a lower group and an upper group. If I scan back up to the one here at the top of the page, this one that I always think kind of looks like a cowboy hat a little bit, that is a bimodal graph. If I think about this, it definitely has two peaks. And also I'm curious, like, is this actually two curves that just happen to be overlapping? You know, would that data be better split into pieces and analyzed? So I've got those two distinct peaks or two groups of data. I would want to mention that. And then finally, another word would be uniform, which essentially means you have a graph that has no peaks, but also the shape is fairly rectangular. Okay, so this one I would say is roughly or approximately uniform. Even though all these bars are not the same height, they're fairly close. And one way to remember that word uniform as opposed to like unimodal, uniform, if you think about it, if a bunch of people are wearing a uniform, they all look the same. So it's like all these bars are wearing the same uniform. Okay, so those are words that we can also use to describe shape. So I start there. The other thing I want to mention, the other part of my SOCS, so I write about SOCS, I've got the context in there, is I want to use the word, I want to look for outliers. And outliers also we want to throw in here, or anything that happens to be unusual. If there's anything that catches your eye about the graph, exceptionally high points that don't fit the pattern, exceptionally low points that don't fit the pattern, or like are there little clusters? Is there a big gap in a certain area where we don't have anything? Those I would want to mention. All right, the second part of this is center. The center gives us a position on the graph. So just like the three classes that we said, on average, it seemed like class A had a higher performance rate than class B or C. Well, we want to place the graph somewhere. Where is the position of this? And center is a very good place to start. Now, typically for center, we are either going to reference the mean or we are going to reference the median as a measure of center. Sometimes, if what's important is the peak in the graph, we might use that instead. We might say this graph has a peak in this area. Or you might say it's got two groups. One group is centered here and one group is centered here, and to kind of give that idea. But the mean and median, that central tendency value, is typically what we would refer to sort of position the data set and explain where it is. And then the final one that we have in our SOCS is the spread. Okay, we always want to mention that spread. So spread is variability. What we're really interested in is the variety of values. Is there a lot of variability? Were these values very different from each other? Or was there a low amount of variability? They were very close to each other. In this first chapter, the kind of spread we're going to be using mostly is range. Okay, and that's literally what you get when you take the biggest number minus the smallest number, the maximum minus min. But this is just going to be for chapter 1. In future chapters, we're also going to talk about interquartile range, which is sort of a spread around the median. And we're going to talk about standard deviation, which is a spread around the mean. But for right now, we're going to stick with range. All right, so we go to talk about a graph, we go to talk about a distribution of data, we're going to mention context, we're going to talk about the variable, we're going to use real numbers, we're going to reference the shape, we're going to identify any outliers or unusual things if we see them, we're going to reference the center, and we're going to reference the spread. We're going to put on our socks and talk about that graph, unless you need your socks off so you can see your feet to decide the distance of the skew. All right. So I've got a little graph here, and this is not in your notes packet. This is just one that I've pulled from a thing. So if you're following on, for one of my students following with your notes, you're not going to see that. All right, and I have this little example. This is a histogram, and I would want to reference this. I notice at the bottom, the variable here is number of accidents. And on the vertical axis, I've got the relative frequency. I notice that this is a count, so this is a discrete numerical variable. I don't have any decimals here. You either had 0 or 1 or 2 or 3. Nobody's got 3.75 accidents here. All right, so I'm going to type this. I'm going to say the distribution of. Okay, now, anytime you want to say the graph of, or the data of, or the dot plot of, the stem plot of, the histogram of, use the word distribution instead. The distribution of number of accidents, there's my, getting that out of the way, that's my context here. I'm using my variable. And I want to look at this shape first off. Now, when I see this shape, it does seem to have a peak down here in the 1 to 2 range. And it looks to be sort of skewed to the right. It has that drifting off. So I'm going to say is unimodal with a peak. And let's see, at a peak at, oh, wow, that changed fonts. I don't know why. And it still did it. Go back again. With a peak at about 1 to 2 accidents. And is skewed to the right, or skewed right. So the distribution of number of accidents is, there we go, is unimodal with a peak at about 1 to 2 accidents. That's what that peak is, and then is skewed to the right. The next thing I'd want to look for is outliers. And I don't see any outliers here. I don't see anything even really unusual happening. There's no points that seem separate that don't seem to follow the trend. So because there's not, I'm not even going to mention it. Next thing I want to look for is center. Now, because this is measured in relative frequency, probably the easiest center for me to find is going to be the median. So remember, the median cuts things in half. And so if we could figure out where 50% is, that would tell us what our median is. All right, so I'm just going to kind of guess here. This looks like about, I don't know, 16%. And this looks like maybe about 23%. So these two bars together are giving me 39%. All right, so if I want to get to 50%, here's another bar that's 23. All right, so if I move over into that next bar, I would be at 50%. And you could add over there on the other side as well and try to get that. So if I go over another 23% here, that puts me at about 62%. Okay, so 50% would land in this bar. I have to move over into that bar to get 50%. So 16%, 39%. I'm not at 50% yet. Okay. But this is like 62, so I know it's got to be in there. All right. So the median, the median number of accidents is 2. And the range is, all right, so we go from 11 down to 0. So the range is 11 accidents. Okay. All right, another thing you could say is that it looks like the majority of people have between 0 and 3 accidents, somewhere there. So you might say, even though the data spans 0 to 11 accidents, the majority of people have 0 to 3 accidents. Maybe that's not necessary, but that kind of gives us a little bit of what is this actually saying? Well, most people have 0 to 3, and there's some people that have had a lot of accidents in this case. Okay. All right, now let's look down here on the next example. Now we actually, in one of my other videos, actually created this back-to-back stem plot. Okay, and this back-to-back stem plot is being used to talk about the enrollment in elementary school or grade school in several different countries in Northern Africa and several different countries in Central Africa. And this is actually opposite of the one we made in the video. I've flip-flopped, but it still has the same thing. So these are percentage enrollment. Okay, so this is 97% in that country who were old enough to go to school were enrolled in school. So I like to do before like a little plan. I like to kind of plan out what I'm going to say. All right, so I'm going to look over here at Central Africa, and I'm going to make a plan about what I'm going to say about shape. So I'm going to tilt my head so that I'm looking at the shape. And to me, this looks unimodal with a peak in the 60% range. Okay. And other than that, it's, I think we could probably call this maybe roughly symmetric. Okay. So I'm going to say, you know, this one's probably roughly symmetric here. I don't see any outliers. Okay, so we're talking about my SOCS. Okay, I don't see any outliers. I don't need to mention that. As far as the center goes, it says that there are 23 countries in Central Africa that they measured. So 23, that'd be 11 on the left, 11 on the right, and 1 in the middle. The half of 23 is 11 and a half. So I need to find the 12th number. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right. So median of 61 here. As far as the spread, I'm going to talk about the range. The range goes from 98 down to 34. So 98 minus 34, that gives me a range of 64. Now on the other side, the shape is a little bit more difficult to see. So I'm actually going to, this feels maybe skewed to the right, but when you look at the numbers, here's 3, you've got 1 value in the 3 stem, here's 4, there's the 8, here's 5, there's 2 of those, 6 had nothing, 7, there was 1, 8, there were 4 values in the 8 stem, and in the 9 stem, there was just like a whole bunch right here, okay? So if you think about this like a number line, so it's going the wrong way. So you can't tilt your head this way because that makes the number line go backwards. You have to tilt your head this way, but then it's difficult to see what's happening, peak and tail. It feels a little backwards. So what this really is skewed to the right. Okay, so we really have just a skewed right graph there. Okay, so let's go back to this. So as far as the SOCS over here, we have the shape is probably skewed to the right. I'm going to make myself a note so I know. Outliers, I don't see any. What about that center value? What is that median? 19 countries in Northern Africa. So that would be 9 on the left, 9 on the right, and 1 in the middle. Okay, so I'm looking for the 10th number. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. That gives me a median of 91. And let's see, what would the range be? I'm doing 98 minus 34, which seems remarkably familiar. 64. Okay, so when I'm thinking about making a comparative statement, when I want to talk about these comparatively, I'm going to use my context. So I'm going to talk about percent enrollment. I want to reference Northern Africa and Central Africa. I want to compare the shapes. The shapes are different. Okay, one is skewed to the right, one is symmetrical. Neither group has any outliers, which I might go ahead and mention because even though there aren't any, that is something they have in common, that they don't have any. And then the center, the median for Northern Africa is much larger than the median for Central Africa. But the spreads are the same. They have the same range. All right, so I'm going to go up here and type this in. All right, so let's go, pull this up. Okay, so I'm going to say the distribution of percent enrollment for Northern Africa and Central Africa. maybe I should say distributions. The distributions of percent enrollment for Northern Africa and Central Africa have different shapes. And I'm just going to, shapes. Northern Africa, which I'm going to abbreviate. I'm going to make myself a little note here. Northern Africa, I'm going to abbreviate that from now on as NA. And Central Africa, I'm going to abbreviate that from CA from now on. Have different shapes. Northern Africa is unimodal with a peak in the 90s. 90s percent enrolled. While Central Africa is roughly symmetric, not very symmetric, but kind of close, roughly symmetric, with a peak in the 60s percent. Okay? All right, so there's my shape. I'm going to say neither distribution appears to have any outliers. Okay. One thing you might want to mention is that the Northern Africa does have a pretty big gap. We have a stem of 6, so we have no values. It actually looks like the numbers from 59 up to 77. So I'd say, however, Northern Africa has a gap with no, I'm running into my notes here. Let me see if I can move these. Okay, move these over. Actually, we'll just get rid of them. Okay. All right. With no values between 59% and 77%. Okay, so there is that gap. That's something interesting. All right, what else? Okay, S, shape. O, outliers. Anything unusual. C is center. Okay, Northern Africa has a median percent enrollment of, what did we say the median was? Oh, I deleted it. 91. Okay, 91%, which is larger than Central Africa's at 61%. Both distributions have the same, let's say, range of 64%. Okay, so that's pretty good, but that's all the pieces. I got all the pieces in there, but what is this graph saying? What is this graph saying? Which group seems to have more kids enrolled? Looks like Northern Africa does. Remember, there's not that many values here, but one thing that just seems to draw my attention every time I'm looking at this, my eyeball keeps coming back to this line at the 60s where there was a gap right here. I'm just going to kind of draw that line. All right, so there are Northern Africa, there's 19 countries. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15 values, or a majority of values greater than 70%. Okay, whereas Central Africa, there were 23 of those. Look at the other side of this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. A majority of these values are less than 70. So it looks like Northern Africa has more students enrolled primary school. So I'm going to say it appears that the Northern Africa countries have more percent enrollment. And I'm going to use this fancy, as evidenced by a higher median, and that the majority of countries have a percent enrollment greater than 70%, while Central Africa's majority of countries has a percent enrollment less than 70%. All right, so I kind of have my, okay, so I've got this analysis. What is happening according to this data? Now, this is kind of older data. It'd be interesting to look and see what it was like now, okay? But we want to try to always ask ourselves, not just did we address the SOCS, so we checked all of our check boxes, but ultimately you want to say, what kind of story is this telling me? Just don't say anything incorrect, but always kind of flavor, why do I even care what the median is? I'm using it as evidence for that this seems to be on average higher than this other one does. Distribution of values. Okay. All right. So when you're talking about numerical graph, don't forget to put on your socks and make sure you discuss context with real numbers.